All right, so we're looking at question 32. Okay, the problem is talking about the decomposition of phosphorus pentachloride. So I hope you're not bothered by those names, phosphorus pentachloride, right? Grade 11 chemistry, penta means 5, so PCl5 must be the phosphorus pentachloride, right? So that's PCl5. And it says that 0.20 moles of PCl5 is put into a 20-liter flask. When you are reading the question, things you want to look for, the units, moles. Moles means you're going to want to switch to a molarity, so you're going to also look for a volume, right? So 0.2 moles in a 20-liter flask, those are going to go together so you can divide them and get molarity, right? The other thing that you want to note there is that that was put in the flask, meaning it is at the initial conditions. Because it's initially there, this is a clue you're going to want to set up the ice table in this problem. This phrase, at equilibrium, is important. That's another clue that the ice table is needed, because we know about the initial conditions and we're told something about the equilibrium conditions. And again, it gives me moles, so I'm going to want to convert that also to a molarity, right? The formula we use to convert to molarity, C equals N divided by V. Write that in your margin if it's not obvious to you. N stands for moles, and V must be in liters, right? If I was nasty in this problem, I might give you, instead of 20 liters, I might mention a 600 milliliter flask. Okay? You've got to have your volume in liters when you're calculating concentrations. We're trying to find the equilibrium constant, so we know we're going to need an ice table, fill it out, take the numbers at equilibrium, plug them into the Kc expression, and we'll be done the problem. Okay? So let's start. You're going to want to start again with the balanced equation. So PCl5 decomposes to PCl3 plus Cl2. In most of the examples we've seen so far, it has been examples of homogeneous equilibria. Everything's been in the gas phase, right? That's nice. We don't have to ignore anything. It will get harder. You'll get heterogeneous equilibria where you have to ignore solids and liquids, right? They're not part of the equilibrium expressions. We said we need an ice table because we were given initial and equilibrium information. And I'm going to need a number from you guys. We were told that you have 0.20 moles in a 20-liter container. Anybody out there can do that in their head? What is the concentration? How about this? I have to divide 0.20 moles by 20 liters, right? Dividing by 10 liters would be easy. Dividing by 10, 0.2 becomes 0.02. Then to divide by 20 would mean to divide by 10 and then again divide by 2, right? So 0.2 divided by 20 gives me what? 0.01 molarity. That was the only thing put in the container, so these guys are going to start at 0. They were not put in the container initially. The question went on to say that at equilibrium, you had 0.040 moles of the PCl5 remaining. So you know you have to divide moles by liters. So 0.04 moles divided by 20 liters gives us 0.002 molarity remaining of the PCl5. Okay? Very little is left. Okay? On the other hand, you didn't begin with very much. You began with 0.01 molarity, right? Which number can we calculate now? the change in PCl5. And I think I mentioned yesterday you might want to use a different color of ink to distinguish what was given in the question from what you're doing yourself, so when you study this later you can figure out what was there and what you basically did on your own. How can you do this, find the difference? So yesterday we had nicer numbers and we could all just figure it out in our heads. If you can't figure it out in your head, then does it make sense you're just going to subtract those two numbers on the calculator? If you began with 8 and you finished with 2, then you must have lost 6, right? 8 minus 2, that's how much you lost. So if you can't do that subtraction in your head, then just pick up your calculator, 0.01 minus 0.002, you lost 0.008. Okay? Someone else might think, well, it's like taking 10 and minusing 2, so yes, you lost 0.008. Since, yeah. This number here, the problem said that you had how much PCl5 at equilibrium, Vladdy? 0.0. Sorry, no, not quite. It said 0.04 moles, right? So that's moles. What did we do with it? You divide by the volume. So 0.04 moles divided by 20 liters gives you this 0.002 molarity that was there at equilibrium. Now that we know one of the three changes, we can find all of the changes. Since the left side is losing, the right side is gaining. Of course, it has to gain because they started at 0. Dear. How I got that change? How I got the equilibrium number? Okay, one more time. Look at the question. Look at your question. What does the question say about PCl5 at equilibrium? What does the question say about PCl5 at equilibrium? You have 0.040 what? Moles of PCl5 at equilibrium. Since it's moles, we need to convert to molarity. C equals N over V. So C will equal 0.04 moles divided by 20 liters. You pick up your calculator and do that, and the answer will be 0.0020 molarity. Okay? All right, so we want to calculate the other changes. And to calculate the other changes, you look at the ratios, right? Every time one PCl5 disappears, you get one PCl3. So if we lost 0.008 for PCl5, you would gain the same amount, wouldn't you? Right? Because it's a 1-to-1 ratio. You also gain 1 mole of Cl2. So again, it's a 1-to-1 ratio. This would gain 0.008 molarity.
But how can the products gain more than
Okay, how can the products gain more than the reactants lost, right? You're thinking there probably about sort of law of conservation of mass and thinking you can't gain more than you lost. That's a violation of the law of conservation of mass. But if you go back and look at this equation, we're not talking about the masses being greater. We're talking about the moles or the concentration, the molarities, right? If you go back and look at this, if you add up the P with 5 Cls and get the mass of that, and then add up the P and 3 Cls and the 2 Cls over here, you'll notice that this guy's mass plus this guy's mass equals this guy's mass. So when you take 0.008 molarity of PCl3 and 0.008 molarity of Cl2, convert that to grams, it will equal 0.008 molarity of PCl5. Okay? So what we look at for the changes are the coefficients, the ratio. Think about a pen with a cap on it. One pen with a cap on it can break into a lid and the pen without a cap. You can get two pieces from the one pen, right? That's basically what we're doing here. One PCl5 is breaking apart into one PCl3 and one Cl2. So therefore, two PCl5s would become two PCl3s and two Cl2s. Well then 0.008 PCl5s would become 0.008 PCl3s and 0.008 Cl2s. Okay? Then you've got 0.008 molarity here, 0 plus 0.008, 0.008 molarity there, and we can now jump in and find Kc. Kc equals concentration of PCl3 times the Cl2 divided by PCl5 concentration equals 0.008 squared. Notice you can save time sometimes if you're multiplying the same thing by itself. You could just write 0.008 squared instead of 0.008 times 0.008 divided by 0.002. Grab your calculator and evaluate that. Someone have the answer? 0.032 is our value for Kc. Okay? That Kc value is not that big. Does that kind of make sense here? Okay, look at the percentage loss and you can decide whether that actually makes sense or not. All right.